Good afternoon, everyone, and thanks for joining us today to learn about our new partnership with GXC and their private 5G cellular solutions. My name's Sam, and I'll be hosting the session today. If at any point you've got a question, please make sure you put it in the Q&A box, and we'll do our best to answer it at the end of the session. As you just heard, the session is being recorded, and you will be getting a link to the recording following the webinar. So you can watch it back at your leisure or share it with any colleagues that missed the session today. So at this point, I'll kind of hand over to Craig, my colleague, who's Sales Director here at Open Reality. He's going to be providing a bit of background about why we're kind of branching into private cellular technologies, and also talking about why we've selected GXC and why we believe they're the perfect vendor to lead us in that area. So over to you, Craig.
Thank you, Samuel. Good afternoon, everyone. Thanks for joining us. Those who I haven't met, my name's Craig. I'm Sales Director at Open Reality. Been here a long time. So yeah, I'm just going to do, I know we have a mix of existing customers and partners, so I'm just going to do a little bit of positioning about where GXC sits within our kind of portfolio and kind of maybe why we've made the move into the cellular world. So I will just get started. So I think it'd be fair to say we're probably most known for our partnership with Ekahau. Over the years, we've been expanding our portfolio of complementary Wi-Fi products with infrastructure, accessories, and monitoring, and that's been pretty good for us. I think we like the fact that we're specialists in wireless. So when we've been looking for different areas and new solutions to complement our portfolio, for us, sort of cellular was an obvious area because obviously, literally it's a broad spectrum. So those of you that keep tabs, our first step into the cellular world recently has been a partnership with Teltonika, who provides, as you're probably already aware, a range of publicly connected 4 and 5G routers. I think it'd be fair to say that in the worlds of public and private cellular we'll cross over, and particularly in Teltonika, depending on the use cases, there could be some scenarios where the Teltonika devices are used alongside a GXC deployment as well. So we do see them as complementary. And obviously, we're really here to learn today a little bit more about GXC. We, again, some of you will probably be aware we've run a really successful Wi-Fi training program. So the ECSE and other flavors, we probably train around 200 to 250 Wi-Fi engineers a year. We're also looking to build that same model into the private 5G space. So we are going to be following a similar template to the ECSE courses, whereby the content is vendor agnostic, delivered by 5G experts. So I know there's a lot of our Wi-Fi partners are interested in moving into the private 5G space, but I think there's obviously an adoption and a training requirement. So as well as the products, we will be also providing training courses. Further information on that is on our website. Obviously, you can speak to some of the account managers as well if that's something of interest. And of course, obviously, we have our own pre and post sales team that can support you guys on this journey if you are growing into and moving into private 5G. Just quickly wanted to sort of share with you some of the reasons why we chose GXC. Obviously, we plan to move into private 5G, and we did, look at the market. We looked at a couple of providers, so I thought I'd share with you quickly some of the reasonings and why we think they're a strong solution. First of all, it's a fully, and Sean, I'll apologize if I steal your thunder on a couple of these points, so they might be repeated, but we really like the GXC with a fully integrated solution. Some of the vendors we looked at were kind of software layer. You had to source the edge servers, you had to source the APs, and that had supply chain considerations and also management, having to use different consoles and the interoperability between those solutions. So we like the GXC end-to-end all-one solution. On a similar note, they've kind of built the solution to be almost like a Wi-Fi controller, single pane of glass, really simplified GUI to set up and administer the platform, which again I think will appeal to our Wi-Fi base that wants a sort of similar experience and in a new world. So we really like that simplicity. One of their really neat features, and bearing in mind, certainly in private 5G, some of the most common use cases at the moment are some of the external, whether they be hospitality, caravan parks, agriculture, shipping ports, airports, big open spaces. Work really, really well for private 5G as well as manufacturing. But and obviously, naturally, with some of these being external areas, running data cabling to these points can somewhat be challenging. So we really like the idea of the cellular mesh, which is a unique and a sort of patented technology with GXC. And then finally, we like the fact that this is what they do. They are private 5G focused. They do LTE as well, but fundamentally private wireless is what they do. And I think our concern with some of the other vendors, whether they were a carrier vendor trying to downgrade their products to work in the enterprise, or maybe they were a Wi-Fi networking vendor that needed a line card for this, and it's one of 100 products and not really getting the focus and attention from an R&D perspective. So we really like the fact that this is what they do, and all of their focus and attention is on private 5G. So overall, and plus they're a very channel focused vendor, which works well for ourselves and our partners. We felt like it was the best solution that we uncovered. So hopefully you guys agree, and we will cover a little bit about the channel structure, and then we'll pass over to Sean. So quite simply, obviously, we are the distribution partner, so we are the representatives in the UK for GXC. So pre-sales, post-sales, assistance with any kind of deployment, really, we're there to support our channel partners, and obviously the partners will be providing the customers, the platform, and also their own professional services and managed services and support. So it's a pretty standard model that we've got on all our other vendors. So that was a quick 5 minutes really to kind of share a bit of background about where it sits with us and why we've chose to work with GXC. So I will pass over to Sean. I'm just going to sharing my screen. Hopefully that will work.
All right.
Yeah.
Can you hear me okay? All right.
Yep, we can hear you.
All right. I'm going to go to slideshow. Okay. So Craig and Sam, I really appreciate the time and everybody here on the call here, and wanted to get just a high level, just a who we are, what we do, and then the idea here was we'd actually do a quick show of our. We'll talk about a lot about the use cases with real world implementation, and we'll also quickly show our GUI, which is the network management system we call Onyx Portal. So that's kind of the flow for this particular discussion. So why would you want? Why is there any need really for an additional networking layer here? And really, we know that one technology won't solve everything. And what we have out there today is, a lot of Wi-Fi, which is great, but obviously it has its challenges. And so every time we're looking for additional, enterprises are always looking for additional ways to protect their data, and also provide at least a really good connectivity. So in the case of private cellular, we try to address where there's some issues in enterprise networking. And so think really where we excel is that indoor-outdoor coverage, seamless indoor and outdoor coverage. And I'll kind of give you some use cases and shows exactly how that works. If you kind of give an idea about the number of access points that you would need to cover an indoor location compared to Wi-Fi, you're probably on an order of 4 to 5 to 1. On outdoor, you're probably closer to a 10 to 1 ratio. And obviously that depends on how it's installed, what it looks like, etc. Then we also, what is great is that all the data resides on-prem. So if you so desire to implement it that way, and we'll talk about different ways that it's implemented. And we've really tried to, in working with Open Reality, right, and with other partners around the world, is trying to make it as close as for enterprise operators, enterprise customers, to be able to have their IT teams or their managed service providers look at it and go, hey, this looks very similar to Wi-Fi, and how I manage my current network architecture within my business. And so we've really tried to drive a lot of the efficiencies and putting it into a single, pane of glass and a single easy GUI to be able to do that and be able to manage and operate that as another network layer within your within an architecture. So cellular in itself, it's highly secure and very similar to what you see on your cell phones today. Your cell phones have, and it's 3GPP compliant, right, throughout the world. It includes an encryption component, actually physical or software layer. Think of a SIM or an eSIM. There's it's the same technology that you use on your cell phone today, but you're putting it at a local level, in a private level, with a SIM and authentication on the network. As we said, you completely own the data. So an enterprise and folks that have the private cellular on-prem, they don't have to share their data. The data never leaves the site. It resides really on their on-prem. And the other is, if you're using a public cellular, when we put public cellular, you think of a MNO, let's say Vodafone, for example, in the UK. You're actually using a public tower, and it goes to yes, you can probably put a VPN and an APN and kind of encrypt it, but still the data is going off-prem. And so this is a really good solution to be able to do that. In really enabling, it complements the Wi-Fi. It complements Wi-Fi. We never tell an enterprise, hey, you need to just swap out everything and use cellular. Wi-Fi is good where we know it, and everyone on the phone knows how well it works and where it works best. But really, it's enabling complex use cases where where extending Wi-Fi or extending another type of connectivity would be very difficult to do. Think very challenging RF environments, where it's not cost effective to deploy, multiple APs to get into there. So on a different technology. And so as well as the and what's great on GXC is that we offer the full stack. And so that helps us to be able to deploy new features and everything that is complementary with private cellular. So as Craig kind of mentioned, what are the kind of the key differentiators in end-to-end private network? And we'll talk about kind of just what that architecture looks like. Again, it was built from the ground up as for enterprise. So we didn't take telco equipment and strip it down and try to give you too much everything that you don't need. And it's not that complex. And then obviously as a bonus is we're the only ones in the world that are able to do a true cellular mesh. And so it's similar to how it's done on Wi-Fi mesh, but we do it on the actual cellular technology instead. And then we own the IP around that. And that's really for, in different use cases where you can't pull fiber, you don't have internet at a specific site or something like that, and you need to be able to extend that network. And you can get, an outdoor mesh, mostly used in outdoor. You can get between 1 to 3 miles extension with a mesh node. All right. So when we mean how it gets it's all in a package is you have the radio access layer, right? So different types of radios on the left, and really we're a software play a lot of times. So out of the box, we have radios that we have tested, fully integrated into our core and into the NMS, and it's out of the box, ready to go. You have some indoor APs and different IP ratings. In this case, this is more of an office and light industrial environment on the left. You have different APs that maybe need more indoor, outdoor, indoor ruggedized. We use these a lot in indoor, like higher IP requirements, maybe industrial type solutions that need to have different IP ratings. And then there's an outdoor version of this, and that is more high power. We use it in outdoor locations. It's also C1D2, so compliant. So if you're in an area, a factory or something like that is in explosive environments, this would comply with being in that. If you could actually put it indoor, and it will comply with that. And so there's different ways that you architect the network, and you have a breadth of radios that give you that access, that radio access layer. This fourth box is our proprietary mesh node when used. And so you pair that with an AP when you actually implement that, if you need it. Again, all of the radios and everything is seamlessly integrated into our a core. So the mesh kit, the core, the radios, the NMS, the orchestrator, the CU, the DU, everything is all within and functions completely within a server that is provided. You can do an on-prem server, as we mentioned. Most industrial and enterprise customers require that or prefer that. You can do a hybrid, and you could also do it a cloud core. So there's different ways, and we help with Open Reality on how to architect what that network would look like depending on the customer requirements. But again, everything is fully integrated. You're not having to go and get go get your own core, do some integration. Out of the box, you can turn it on and it fully works. And I'll show you a picture of a kit, for example, that I use as a salesperson. I can set up my network within about 5 minutes. You can, in a Pelican case, open it up, turn it on, it registers, and within about 5 minutes, I can demo to a customer the Onyx portal and or a connected UE, etc. And obviously we have this a network management system. This is we'll kind of click through a couple of slides or a couple of the Onyx portal to show you this, but this is how you manage and operate the system. Looking at usage, users, devices connected, and any statistics around the network itself, and we call that the Onyx portal. And then you can provide both physical SIMs and eSIMs. And the eSIM is kind of a QR code, one-time based system. So if your end user devices are eSIM compatible, you can actually use a eSIM. So that is the full inside. That is the system that is GXC Onyx and the private 5G. Here's different ways that you can use the system. So on the left, you look at, okay, these are native enabled 5G devices. So, maybe it's got a wireless, so maybe a tablet or an iPhone or an Android phone or Android, maybe a scanner of some sort or industrial PC that is cellular enabled. As long as it is able to accept a SIM, it is 3GPP compliant. It's unlocked, right? It serves the bands that are deployed. So in the UK, typically that is in 77. It's in a certain spectrum range. And most of your 5G devices especially your consumer devices from about, let's say Apple OS 12, 13 and beyond, all are able to accept a secondary SIM or a primary SIM unlocked and talk on an available private network as long as it's authenticated. So those are natively connected, maybe tractors or machines that have here. And then the other way that you typically can deploy is you can use the private cellular as a backbone. So you see this this router. So think of like a Telefonica router that you have that's available today. They have a front haul, so front haul or connectivity into Wi-Fi or Bluetooth or some sort of LoRa, possibly a LoRa, and then backhaul over a cellular network. Well, that could be public, all right, which is, over a public network, or if it had a SIM that was a private cellular SIM, on specifically GXC, then you can actually backhaul instead of the public network. You can backhaul the data into the private network itself. So you can use these gateways and routers and ways to extend network either cost effectively for Wi-Fi instead of rolling cable and pushing it out there. This could be used. There's also Ethernet. There's dongles, USB dongles. There's Ethernet modems, that are just that you can plug into maybe a machine that has an Ethernet port for network connectivity, and that will then authenticate with a SIM, right, and authenticate on the network. So there's different ways that you can use the network itself, either natively from SIMs that are available for cellular, or you can extend with gateways and routers, and all of that data then resides on the private network versus going out on the public side. And this kind of gets a little everywhere it says CBRS, just think that's the private network. That's depends on where you are in the world. In this case, it would be the private cellular 5G connectivity. But again, this is high level, the architecture, how it resides. So in the center, as I mentioned, you have the Onyx on-prem server. You can do a VM multi-site, depending if the servers are available. For enterprises that are looking to have high availability, there is high availability opportunity functionality here, both physically and hot backup or standby backup as well. And then you have the core server, again, all as part of this core area. The EPC, the users, the MME, and even some of your other, the CU, the DU, everything that runs the network itself. And then you have, again, here in the below, you have the radio access network, and those are the radios that we talked about that extend the network or access points, right, depending on where you need to put that. Oh, sorry, yeah, that was real touchy. And then we talked about, if you need it, you can use a mesh network to extend the network. And typically that's in use cases where you only have power, but you don't have backhaul. And then you can extend this through user-used devices, or so this is extending the network with routers or gateways or things like that to your actual use cases. There is VLAN, so you're able to partition the network depending on the use case, and we'll kind of talk about where that and all the way down to the device level. So you could call it VLANs. You've heard micro slicing. You've heard vSlice, whatever. Again, the point is that you can manage the network how you want it from an enterprise perspective. The other one is that you can one of the big benefits here is there's a lot of these machines or different devices. For example, forklift, it's heavy uplink versus downlink. So the public network today is typically geared toward streaming and Netflix and everything else that's heavy download or downlink. Not a lot of uplink. Well, in the case of your private network, you can actually adjust that. And make it heavier uplink, less on the downlink, depending on the use case which is great. That's something that you can't do, with a public cellular. You can't call up your Vodafone and say, hey, can I get a site that has a tower with a, heavy uplink? They'll be like, no, okay, not available. In the US, we have the SAS, which is a kind of a SAS registration for the network. This is more of a US based application. In your case, really, and Open Reality helps to make sure that you have the available spectrum and the in the UK to be able to use at the location at the power levels, and that's part of your deployment architecture itself. And then you have the Onyx portal. And the Onyx portal, we talked about it. That you can extend it through APIs if the customer wants to embed it in some sort of other operational mechanism or software layer. All good, or you can use the GUI. So again, all in. This is the offering that you can provide to a customer, and really it opens up a lot of different avenues to different services of integration, of installation, of management, of extending different use cases and different devices that will appear that you shouldn't do before. So there's a lot of opportunity here. Yeah, I'm gonna go a little bit. I think I already kind of talked about this. We try to be, when we say lowest cost in the industry. So in this case, really, we're a software company. We're not hardware. So we don't sit there and jack up the prices of the hardware. We're not making a lot of our margin. It's on the software. So we try to make it where it's cost effective, and it feels not only the look and feel of a Wi-Fi, but also a similar price points that you can architect a managed Wi-Fi system. And then if you throw in the mesh, right, then you're lowering the need to be able to have to trench fiber to every node or AP, or provide some sort of a backhaul. And it's flexible. And what I mean by that is today we're on 4G, 5G. In your case, it's 5G. That's mostly deploying today. That core that you deploy or have available is continually updated with new features. You can run in the future when 6G comes out or 7G, that same core, maybe a different radio layer, but the same core was there to be able to operate both backwards compatible as well as future proofing. We continue to add features, different things that the customer might want, or different types of connectivity use cases that people want either inside the portal itself or as part of a overall operational deployment. So we kind of talk about the bands and frequency support. There's a lot of bands here, a lot of frequencies, but in your case, you would look at band 77, 78, and those are the radios that when you engage with Open Reality and GXC, we're going to be looking at the radio architecture of either a ORAN 5G architecture or a G-Node B, depending on the type of network architecture you look at. And it's going to be on the N77 spectrum that's allotted towards shared spectrum that you can get a hold of at a very, very, very low cost. And the Open Reality is kind of the specialized how to get access to that to be able to use the network once it's up. But there are other areas. So for example, if a customer of yours says, hey, by the way, I really like it here in the UK. I'm going to be in Germany. I've got maybe different areas in the EU that they use a 77 or 78 as well, or in the US or Latin America. There's other bands that we have different radios that can work. Still using the same central core, still using the same software to be able to manage that. And kind of get an idea of throughput, you know, and bandwidth. You know, most of our current use cases can really be solved around 4G, but everybody wants 5G. Fine, you know, we'll move to that. um, you're typically going to be in this Onyx 5G, depending on the size of megahertz available that you're granted, anywhere between 40 to 100. And you can kind of see the speeds depending on the, you know, everything is a 4x4 MIMO. This downlink speeds greatly, you know, is affected depending on the amount of bandwidth that you're available at that location. Most of the customers are getting between 50 to 100 megahertz granted. You know, peak uplink, again, you can, you know, again, as part of the ownership of your own private network, you're able to manage, you know, how much uplink and how much downlink. And this kind of gives you an idea of use cases that really are needed for either 4G or 5G. 5G is really kind of an overkill right now for most use cases, but when you get into live 4K cameras or even robotics, where and edge AI applications that are heavy compute and a lot of data with low latency, and you need extra bandwidth, definitely that 5G is where you go. But most of our use cases that we would do from an industrial perspective can be handled with 4G as well. In the UK, everything is 5G. So we would never really be looking at an LTE system with you guys, with you folks. So that is, so just real quick, who we are. That's kind of the overall who we are. What I would say is we were born, just so you know, we were born in the basement of UT Austin with a graduate professor and a couple of grad students back in the early to mid 2010s. So I think it was 2016 is when we actually launched. And so really it's heavily engineering teams that support. And you know, we've got a lot of really native knowledge around 5G, especially on the mesh side. We're the only ones that do that. You know, this is something that's really exciting, I think, for folks that are looking for a different technology, something that they can use that allows them to be able to provide an additional service. In the case of just as a side note, really what kind of triggered the mesh network is these guys are a bunch of physics professors and students. It's they were all about you know, using they were photonics, essentially was the biggest use case at the time, which actually transitioned to be able to do our mesh, which is using interference cancellation and filtering and leveraging light and some other stuff that's way over my head. But again, what allows us to be able to provide this today from a private cellular perspective. So that is kind of where we stopped. Then I also wanted to kind of show you kind of what, and make sure Sam and Craig, are you able to see this additional slide? Sorry, the GXC portal, when I go to a different tab?
No, I can just see the private cellular use cases slide at the moment.
Okay, so that means I have to stop share just a second. I gotta flip over to a, I'm gonna share this. So I'm gonna flip around a couple of screens. So real quickly, this is the, you know, as a customer, right? The Onyx portal, as we call it. And the dashboard, again, you're able to see the, you know, the edge. The edge is the server. Is it online? What's its status? The access points that are deployed in with the network, what its status is. The mesh node acts as another node. Does it have an online service? Is it ready to go? And then you have different venues that you can actually create under under your Onyx portal. So if you have multiple customers or multiple networks to be able to manage, you're able to be able to toggle and see, how it is working. Total number of the number of subscribers you might have, which is again the number of SIMs that you're using. You can see download and uplink traffic. In this case, right now the network is not running at the moment, but again, it's very similar to be able to look at some that are. Venues, as you said, you can go to the HQ. You could get, this is where we actually have our headquarters. This is the network on the top of the building on 10,000 Network Boulevard, Metric Boulevard, excuse me, in Austin. You can go and dig into the Onyx Edge. This is the actual Onyx Edge. And again, the server that's online, and you can drill down to be able to see all the attributes and troubleshoot if needed. You can go down to the individual AP from that equipment, and you can see how it's interfaced on the, how it's functioning on the network. And so again, if you look at this, it's very similar to it feels kind of like how you're managing a Wi-Fi network itself. Here's the like the number of subscribers. You can drill down to the actual MZ, right? And you can show different as you manage your your devices that are registered on the network. Drill down to the individual MZ and see the data throughput and the usage, how it's registered, what its authentication keys and OPCs and everything else that you need to do to be able to manage that as well. And so this is the actual this is the Onyx portal itself. I think going through in a more detailed demo would be appropriate on a separate venue, and especially if you've got some questions around the customer itself. But again, what we wanted to really show is how easy it is and understandable how you can see it and operate the network and manage that network as well. So that is the Onyx portal. So the area that I really get excited about is use cases. So what I want to do is I'm going to show a couple of real world. For some of this, cancel. Please select the thumbnail. Yes, I got it. Yeah, here are a couple of real world customer success stories, and then I'll also go to a few actual deployments of what it looks like. So this is more high level. Industrial manufacturing is a big one, right? Think about the challenging RF that you see there, and we'll walk through a customer that has had a deployment for itself or a use case, right? But here is an oil refinery. This is actually out of Houston, and essentially what they were doing is instead, if you look at that refinery, it's a rat's nest when it comes to RF. If you look at it, you're probably like, oh my, how do you get connectivity in that section? One of the big challenges is that they didn't have fiber. They didn't have network or cabling pulled throughout the whole facility where they needed coverage and think of operational locations, not in the administrative areas. And so they were able to deploy a combination of wired APs, right, as well as the mesh nodes. And you can see the differences between the coverage between when the mesh nodes were turned on versus with the existing radio access network without the mesh nodes. And you can see that it definitely extends the network cost effectively, and you're able to get really good penetration and connectivity for their use cases throughout that refinery. It's very attractive on venues, and we talk about stadiums, but maybe campus environments, right? So UT Austin was one of our first way back in the day. This is so we have deployed completely on the campus of UT Austin, as well as in the robotics lab, where they were doing a lot of R&D around robotics and needed to have a separate network and a high available network there. And being able to provide, connectivity throughout the campus. Again, this, as you can see, this is a very deployment on the right with the Omni antenna. There's the radio on the bottom of the bottom of the pole, right? And then this is deployed throughout the campus wide, and able to connect the robots or delivery robots throughout the campus, as well as in their lab itself. Here's another one. It's kind of an interesting one. This is out in Texas. Actually, this is actually a decent use case, I guess, at Open Reality when we were discussing with a potential customer. They have these RV parks or mobile home parks, or where, and in this case, this is in Texas. It's crazy. This is a mobile home, an RV park where these people bring in a couple hundred, $500,000 to $1 million RVs out in the middle of nowhere, and they want to be able to stream their 4K content in the evening, and they have the Wi-Fi coverage, can't extend it, and to be able to extend the 5G, in this case it was 4G, to be able to deploy a network from the office building itself, and be able to deploy these. They were basically Teletonica routers that would accept a CBRS signal and broadcast a Wi-Fi within the RV. And so this was a high throughput. We were pumping, we're pumping terabytes of data per day. But anyway, point is that this use case was really demonstrating how a customer could implement a fully redundant network, and actually increase and actually add an additional revenue streams. They would check out for a period of time one of these routers for a week, and be able to provide access to these broadband to the customer itself with success. Here's agriculture is a big one. Smart farming. I don't really see a lot of robots that look like that out in the field, but here's where is a real deployment. This is on a grain silo, actually. And what it was providing connectivity to I guess existing sensors. We're also deployed on a research farm for Ohio State, and I'll show you what that looks like. But that you're providing connectivity to autonomous vehicles. You're providing a private network of research and or production stuff on the tablets where they couldn't get internet access today. And we're able to we deployed a 2-node system, similar both at Fargo, North Dakota, but also at the Ohio State lab, 2,100 acres with two APs, and be able to have about 20 to 40 megabits per second for which is decent for their coverage needs that they needed there. And here's kind of, this is the Ohio State, sorry. This is the kind of the equipment, what it looks like, how it's deployed. Again, this is on a 150-foot grain silo. They had the main wired node at the office at about 50 feet. The mesh node was 1.5 miles away at 105 feet. And this is their coverage that they received using a wired node and a mesh node. One of the interesting things for us is that you can actually multi-hop a mesh node. And so actually, if there's another connected farm up at the top, they're actually deploying a separate mesh node there, where then you can do at least a 2 hops to extend even greater coverage and greater throughput. Urban enterprise networks. This is something that you see this both again a campus environment, but maybe also you have within a network within an urban environment. We would say maybe office to office building or a campus to campus that you need. Again, deploy those either. Typically they're rooftop mounts, as you can see with cinder blocks and a sled, right? Using existing power in the network within that building itself. This was Onyx that was deployed. It's deployed in downtown Austin, and it provides connectivity, a separate network for the office. I guess it is, an enterprise in this location here. So that is good. Let's go look at some other real. So I'm going to stop share here. Let's see. Okay. Yeah. These are more generic, but I will, and because I've got to be conscious of time here. Got about 5 minutes left.
We've got quite a few questions to get through as well, Sean.
Yeah. So 3 minutes, 3 minutes more, and then we'll open it up to Q&A. So top cellular private use cases. I don't want to repeat too much. Automation control, safety and security monitoring, usually via video. You're seeing more and more AI edge analytics that are happening in the video, and they need higher throughput, extension of the network. A lot of just straight connectivity, workforce connectivity and asset tracking through applications of scanners and tablets. Data analytics, so it's just in itself, just pulling sensor data all the way up to high throughput data. You're really seeing how can I typically, instead of extending through Wi-Fi in these industrial type challenging RF environments, how do I use the private cellular today from a network perspective? And so, yeah, I'm gonna, since we're little less on time, I'm gonna stop there, and I'm going to open up, I guess, for questions, right?
Yeah, Craig, do you want to just finish your slides and then we'll do Q&A?
I could do that afterwards if you want.
Okay. Yep. Yeah. Okay. So first question, Sean, which versions of 3GPP are supported?
Yeah, so currently we are release 17 on 5G.
Okay, great. Next question.
And I will say release 17 on multiple features, or probably full featured at release 16, but release 17. So we, as a different release comes out, we integrate that within the system. Yep.
You touched on it a minute ago. How many hops are kind of possible or viable with the mesh nodes?
Yeah.
Is it just one, or can you do more than that?
Well, yeah, we recommend no more than 2. So in other words, that would be a wired asset AP and then 2 mesh nodes. Most of our customers are really only 1. We have very few that have, hey, I need another multi-hop. And the only places that we've seen that is typically maybe in a mining high, output, a mining application where they need to be able to extend that network. Just to add that you might ask, like, power consumption of these APs. So very interesting use cases is actually, a solar trailer. especially on the mesh nodes. So we're seeing in agriculture and mining and energy where they'll have a solar trailer that they can hook up to the back of their truck and move the network where they need it, and then has maybe a mast level of 30 or 40 feet, and be able to deploy a mesh node with just cellular, with solar, and even be a permanent situation as well.
Again, I think you might have covered this when you did the Onyx demo with the venues, but you can manage multiple sites in the one pane of glass, can't you?
Okay. Yep.
Yep. Perfect. Are the
Sorry,
products
Sam, just an extension for that, and sure, and again from a multi-tenanted, we'll have MSPs on the session as well, so there could be a multi-site, but also multi-customer if you were managing.
Correct.
Okay.
Yep.
Are the products TAA compliant? I think that's coming from somebody from the US.
They are TAA compliant. Yes.
Sorry, I'm rattling through these.
And I think a reason for that is so one of the things that I didn't mention is that we actually have done our first contracts were for the DoD and some other government 4G and 5G implementations, which were required for TAA. All software as well is built and owned US. So again, a lot of issues if you're trying to offshore too much into certain countries. So we're fully compliant for that.
Got a question here. I don't know whether you want to help with this one, Craig. Do you provide support around sourcing spectrum applications and licensing approvals?
Yeah. I mean, the Ofcom website's pretty good. I mean, there's people that are running trials. There's trial and innovation licenses. Obviously, there's the website's pretty good because you can also search for licenses that already exist in these areas, ones with low band, mid band. But certainly, we can absolutely help, advise, and guide, and complete any licensing application processes. So happy to help. But yeah, the Ofcom website is pretty good with the process to apply, and most of it is fairly straightforward. I mean, there is a bit of most licenses they're probably saying sort of 6 to 8 weeks, so there is a sort of delay in getting that approved. But certainly, we can help guide through that process.
And I can kind of expand on that a bit. So it depends on the country, right? So we, as Craig was talking about, specific to the UK, US, we kind of mentioned CBRS SAS. It's a spectrum allocation service, and then you have to start and register with that. That is all within the portal and is done as part of your quote unquote subscription, right? With the software. Outside of the US, and it depends on the country. Most of the times the enterprise for that particular country are familiar with requirements. We help them with, providing detailed information on how to apply, what the answers to Q&A, but they typically will apply for the license themselves, depending on the governing body and how it's done. What we are seeing in the 5G, a lot of, around the globe, LTE is pretty chopped up because it's a legacy technology. When I mean by chopped up, it's, people are using it in different ways. We're seeing most of the world using a shared spectrum in the N77, 78, similar to the European model, and without a SAS side, that's a US thing. So we're seeing on 5G a lot of that consolidation around anywhere from 10 megahertz to 100 megahertz on the 3700, 3800, 3900 plus.
Thank you. Can you manage bandwidth per subscriber?
So the answer is yes. You can by subscriber, so you can go down to the SIM or the IMEI MZ of the device, and you can manage different, go down to an uplink or a downlink heavy, and the bandwidth required on that. Yes.
Is there any risk that the private 5G can interfere with a Wi-Fi network that's on the same LAN?
So we haven't had that. Well, first of all, it's a different frequency. Okay, so Wi-Fi 2.4, 5, 6, whatever. In this case, it's 3. So 30 N77 ranges anywhere from 3.8 to 3.95 plus, something like that. So we haven't had any issue where it's interfering on the same network to date. With that said, there may be some issues there in the future, but so far so good. And then there's different ways that we help in the networking side to be able to, if there are any issues integrating, we understand networking can support different ways that they can integrate into an enterprise network infrastructure.
Okay, I think we've got time for maybe one more question before I hand over to Craig. Like I said on the chat, though, any questions that we've had time to answer today, we'll reach out to you with an answer either via email or over the phone. Is the eSIM capability third party or is it integrated into the solution?
It's integrated into the solution. So when you currently today, when you deploy a system, we allocate eSIMs or physical SIMs per network. If you need more, there's a fee for it, a one-time fee, but again, those are integrated within the system that it's specifically allotted for. Yeah.
Thank you very much, Sean, for answering those. Craig, do you want to quickly wrap up?
If I share it straight away, will it? Oh, I've already done it. Seeing that okay? Okay.
I can see that.
So yeah, just really to wrap up, please reach out to your relevant point of contacts. If you guys are looking for kind of pricing brochures, we've got those readily available. Equally, if you want to go into any more detail on a one-to-one basis, see a bit more of an in-depth demo, tailor some of the things to your particular requirements, we're happy to do that on a one-to-one basis. The next point is really important. I think, and I said earlier, there's a lot of our partners of Wi-Fi. The cellular, private cellular is a new world. So we really want people to know that we and GXC are happy to help, whether that's specifying a solution, doing a kind of predictive design. And I'll probably note we are, obviously we come from the Echo world, and we are doing a little bit of a market review on some of the tools that we can also help to deploy and design a cellular network. But for now, absolutely help with designs, implementation. So pretty much, we would want to support any early stage opportunities, and actually naturally most people want to be self-sufficient. So but yeah, very much that's available through a combination of ourselves and GXC, and I suppose an extension of that, there are options with regards to once requirements are specified, we will have some mobile kits. We've got some options that we can discuss individually if you guys need to run any tests or pilots on these products, really. So yeah, like I said, reach out to your relevant contacts. Happy to have some discussions about your requirements, and yeah, looking forward to working with you guys, really. But yeah, Sam, that's I just want to say thanks for your time. Thanks, Sean. But yeah, Sam, if there's something else we can wrap up. And
yeah, the only thing I've got to add is obviously in the meantime, please go to gxc.io or openreality.co.uk for more information about the solutions. And yeah, we'll be in touch with anybody that's asked a question that we've not had a chance to answer today. Thanks again, Craig. Thanks, Sean, and thanks everybody for attending.
thank you.
Thank you.